This is notes for section 2-3 of Algebra 2. So if you are gone, you are watching this video, hopefully. This is talking about end behavior of functions. So like what functions do as they travel to the left and travel to the right of a graph. Okay. Before we get into like end behavior, we're going to talk about some functions. So I'm going to give you some background information up here. We did linear functions in the past, y equals mx plus b. And those look like straight lines. Beautiful. They look like straight lines-ish, something like that. Now, they could have a negative slope, but most of the time they look like that, okay? Then we've talked briefly about quadratic functions, or x to the second power. Do you remember what that looks like?
Parabola.
A parabola, like this guy, okay? And then we talked briefly about y equals x to the third power, Tony.
This thing.
Like this thing, yeah. So this thing right here, that's what x to the third power-ish looks like, okay? We have not talked about what y equals x to the fourth power looks like. Do you want to take a stab at that one? No? No, that's 1 over x. That's 1 over x. X to the fourth power looks like this guy right here, but he's got an extra little hump in him. Right? X to the fourth power, yeah. Let's do one more. We'll do x to the fifth power. Sure, why not? X to the fifth power does this thing. That's y equals x to the fifth power. Okay? So if you haven't yet, do you notice a little bit of a trend between these 5? Okay? If you look at this one, or this one, or this one, the ones that I've just starred in orange, what's happening to them?
You're getting more squiggly.
You're just adding a lump basically every time. Like it's starting down here and it's ending up here. Starting down here, ending up here. Starting down here, ending up here, right? That's what's happening. Oh, I didn't make this bigger, guys. You're supposed to tell me that. Make that bigger. All right, so it's starting down here, ending up there. Starting down, ending up. Starting down, ending up, okay? If you look at the ones that I'm starring in green, what's happening to those? Up and up, up and up, right? Okay, now, the rule is if it's x to the first power or x to the third power or x to the fifth power, it's going to follow this trend, right? Start in one corner, end in the other corner, all right? So any odd functions are going to be opposite. Any odd functions, like x to the first power, x to the third power, x to the fifth power, they're going to be in opposite directions. Any even functions, which were the ones in green, what happens to those? They are going to be in the same direction. Now, do you ever have something where it's facing like downward? When does that happen? When it's negative, okay? But they're still going to be both in the same direction. They're both going to be down, right? What happens if you do a negative x to the third power? It starts here and ends down here, right? Okay, so that's just, but it's still going to be opposite directions for odd powers. It's the same direction for even powers. That's kind of a trend, okay? So over here, this is how you describe end behavior. End behavior is basically what is the graph doing on the left and right? What graph does on left and right sides? What does the graph do on the left and right side? So over here on the right side, the graph is going up. As the graph goes to the right, it's going up. Okay? As the graph goes to the left on here, this one is going down. Does that make sense? Yeah? Okay? This is how you describe end behavior. So every time on your homework assignment, it asks for end behavior. What you're going to do is you're going to write out x approaches, what's this symbol? Infinity. X approaches infinity means as x's are getting bigger and bigger and bigger. So as x's are going to the right, y is approaching something. And then all you have to do is fill this blank in. All right? And as x approaches negative infinity, which means as it's going to the left, what's the graph doing, or what is the y coordinate doing? Okay? So here, we're going to go ahead and fill this blank in. As the x's are going to the right, my graph is going up. So is this going to be a positive infinity or a negative infinity? Positive infinity. You're just going to put that symbol there, okay? And as the x's are going to the left, or the x's are getting smaller and smaller to the left, approaching negative infinity, what are the y coordinates doing? They're getting smaller and smaller also because it's going down. So this is going to be negative infinity also. This is how you describe end behavior, okay? Yes, yes, you'll write this out every time, and then all you'll have to do is change the whatever's in the blank. Okay, we'll do that down here on example 1. I'll show you that. Okay, so do a couple more on this one. As x approaches infinity, meaning as you're going to the right, as the graph is going to the right, the line is going up, right? So what goes in the first blank? Positive infinity. Okay, as x is going to the left, means as you're going this way, my graph is going down. So what's happening to my graph? Negative infinity. Do you see how this works? Okay, and this one right here, as my graph is going to the right, right, it's going up. So positive infinity again. As it's going left, it kind of looks like it's leveling out, right? It kind of looks like it's leveling out. But we don't know for sure like where this point is at. Let's just assume he's going down and down and down forever. So let's just say that he is at negative infinity, okay? Let's just say he's continuing to go on down forever. I'll show you what happens here in just a second where he levels off and he doesn't move. Okay, we'll do one like that. All right. So example 1, on each one of these, it says describe the end behavior. You're going to have to write out as x approaches infinity, comma, y is going somewhere. As x approaches negative infinity, y is going somewhere. And we're going to figure out what goes in those blanks. So every single time, you're going to fill it out just like that. Okay? Just like that. I'm going to do that over on this side for B. As x approaches infinity, what is the y coordinate doing? As x approaches negative infinity, what is the y coordinate doing? You're going to set each one of these up exactly the same. And then all you have to do is change what y is doing, depending on what your graph of y is doing. Okay? So this is my function. This is a linear function, by the way. So as the linear function, as my x's are approaching infinity, so as my graph is going to the right, it's going down. So what happens to the y coordinates? They're going to negative infinity. They're going down, down, down forever and ever and ever. Okay? And then as we're going to the left, it's going up. So y is going to positive infinity. Okay, you see how this works? Beautiful, beautiful. Okay? B. Okay. As x is going to the right, what's the y coordinate doing? It's staying the same. Same at what? At 4. Y is staying 4 as my graph goes to the right. As my graph goes to the left, what is y going to? Staying at 4. Okay, so that is the only time that you'll have something like that happen unless you have a value here where it like levels off, in which case you'll have a number here as well. But we're just going to assume that that one continued to go on down because I can't really tell. Okay, good? All right, so these are the same type of thing. I'm going to have you go ahead and do these, and then we'll come back. So I'll write out mine, but you go ahead and fill these blanks in. Everything stays the same until you fill the blank in. Yes, go ahead and do both of them. I'll give you just a second to do this. If you're watching this video and you are already done with this part, you can skip forward until we start going again. This one, yeah, as x goes to infinity means it's going to the right, yes. It doesn't matter if you write them in the reverse order, Caleb, it doesn't matter. Negative infinity means left or down, whether it's with x or y. So if you put negative infinity next to the y, that means you're going down. If you put negative infinity with x, that means you're going to the left. That makes sense. Negative infinity, this slot means it's going down as it's going to the left.
Okay, so that one would be x.
What?
So that one would be x.
With the x that left. Yep. Okay. All right. Good. All right. On this one, as my graph is going to the right, what's happening to it? It's going down, so the first slot should be negative infinity. This means right. This means down. Okay? As it's going this direction, it is going down also. So as it goes to the left, it's going down. That's basically what that means, that notation. Okay? On part B, as x is going to the right, what's happening to my graph? It's still going down. So right is down again. You don't have to write right and down, but I'm just helping you understand this. And as my graph is going to the left, it's going up. So infinity. Left and up. Does that make sense? Okay. Now the reason why they discuss end behavior is going back up to the top here. We have the same end behavior happening for odd functions. So here, as x goes to the right, it's going up. As x goes to the left, it's going down. Same thing with the third power. And the same thing with the fifth power. But in the x squared, as x goes to the right, it goes up, and x goes to the left, it goes up. Right, it goes up, left, it goes up. It doesn't matter, okay? So they're basically saying that these functions are going to have the same end behavior if they're odd, and the same end behavior if they're even, okay? And this is the notation that we use to write it, okay? All right, down to the bottom. You guys have any questions so far? Okay. All right. Relative maximum and relative minimum. There's a lot of stuff in here. You can read those if you want to. Oh, look at my cursor. You see the little hand? Ha. Okay, so he's in there. Relative maximum and relative minimum. This is a minimum and this is a maximum. Okay, in relationship to all of the points around it, those are the lowest points. Okay, those are the low points. So they call them relative maximum and relative minimum. All right, basically where hills and valleys occur. All right, flip over to the back side. The relative maximum and relative minimum are also referred to as turning points. Okay, so if I look here, this is a maximum. And it is called a turning point because it's going up and up and up on this side, but then it turns around and goes down and down and down on the right side of that point. So it's where that point kind of turns around. If you think of like a U-turn, I'm going one way and then I turn around and go the other way, right? That's what happens, okay? Same thing with here. It's going down and down and down on one side of the minimum, and then it turns around and it goes up. So that's why they're called turning points, okay? These are also called extrema. Those are extreme points. Okay, extrema or extreme points happen at those hills and valleys. All right, so we have like 3 different names for the things: max and min, turning points, extrema. Okay, so if they refer to any of those in your homework, you'll know what they're talking about. All right, now example 3. You have the graph of this thing over here, and you have the table that corresponds to it over here. So let's look for some low points. I see a low point there and a low point there, and I'm going to do in a different color a high point here, and that's all I see. We don't consider these left and right sides because those are going on forever, and I don't know if they turn around and go any other direction. So we're just looking at those 3 points, all right? And they want us to estimate where those points occur. So I can look at that graph. It's happening like in between points, right? If here is my y-axis, this point right here is happening at an x-coordinate of like negative 1.3, let's say. I don't know. Negative 1.3 is where this first purple dot occurs, okay? And the second purple dot occurs maybe at like positive 1.7. I don't know for sure. Positive 1.7, Okay, but I can look at the table of values to the left side of this, and it will help me tell where those maximum and minimum points are. Okay, so if you look at the x coordinates here, that's great. We're going -2, -1, 0, 1, 2, 3. Great. Oh, this is really fuzzy. But if you look at the y coordinates, it's starting at 7 and it's going to 2. And then it's going, so that's going down, right? It's going down from 7 to 2. But then it goes from 2 to 3. It's turning around and going back up again. So somewhere between, let's see, somewhere between -2 and -1, it's turning around because then it's going back up again. Does that make sense? And that's where my point is at. -1.3 is between -1 and -2. That's where it turns around and goes back up again. Okay. Then looking at this table again, it's at 2, and then it goes up to 3, but then it turns around and goes down to -2. So somewhere between, let's see. Is it -1 and 0? No? 0 and 1. Where is that green dot at? Somewhere between 0 and 1, it's turning around and going back down again. Does that make sense? Okay, somewhere around a value of 0, it's turning around and going back down again. Okay, and it's actually to the left side of 0. I'm going to put just the circle around 0, and I'm going to put just the circle around -1. Don't put the circle around both of them. So just the circle around -1, just the circle around 0. Okay, because I don't know if it's on the left side of -1 or the right side. Okay, so the green one is for the high point. Okay, because it's going from 2 to 3, which means it's going up, and then from 3 to -2, it's going back down again. So it's turning around somewhere close to 0. Okay, and then if we look at -2 to -1, then it's turning around and going back up again. So somewhere close to +1, it's going to turn around. Let me do purple. Somewhere around +1, it's going to turn around and go back up again. So a min here, and a maximum value there, okay? Because it's turning around at that point, from 7 to 2 it's going down, and then from 2 to 3 it's going back up. So somewhere around -1 it's going to have a minimum point, okay? From 2 to 3 it's going up, and then it's going back down again. So somewhere around 0 it's going to turn, and then from 3 to -2 it's going down, and then from -2 to -1 it's going back up again. Does that make sense? You see how that works? -2 to -1. -1 is higher than -2. Okay, it's turning around and going back up again. Where it was 3 to -2 was down. Okay, so this table you can kind of see those values: the min, the max, the min again. The graph is going to help you the most to find the maximum and minimum. But not only that, we have to find the zeros. Do you know what a 0 is? You will by the end of the school year. A 0 on a graph. A 0 is a place where it crosses the x-axis. I'm going to do this in orange. This point right here and this point right here where it crosses the x-axis. Those are zeros. Where it crosses the x-axis is at zeros. Okay? Now we can use the table to find these values also. Okay? So if I look at the y coordinates, where am I going to have values of 0? If you look at 3 right here and -2, it crosses from being a positive y coordinate to a negative y coordinate between 3 and -2. Does that make sense? It's going to cross over. So somewhere between 0 and 1 is where my zeros are going to be. From 3 to -2, it's becoming positive and negative. So it's hopping over 0 right here. It's hopping over a 0. So I'm going to have a place where it crosses the x-axis between 0 and 1, and I do. Okay? Then over here, I've got, again, between -1 and 42, it hops over 0 there. It changes from negative to positive again. So I'm going to have another 0 between 2 and 3. Does that make sense? It's hopping over top of 0. So I'm going to have a 0 between 2 and 3. And if you look at the graph, this coordinate right here is somewhere between 2 and 3. It's really close to 2. but it's somewhere between 2 and 3. Does that make sense? So when they ask you on your homework assignment, where do the zeros live? Just give me where they live between. They live between 0, 1, and 2, 3. I think they'll ask you what two values do the zeros live between 0 and 1, and between 2 and 3, because it hops over top of 0 at a y coordinate, and then you look at the x to see where the 0 is located. That make sense? Okay. Now down here, example 4. The cost of an orange changes over the course of a year. It just depends on when they're in season, right? Like I go to buy strawberries all the time, and sometimes they're like really expensive, so I don't buy them. And sometimes they're like super cheap, so I buy them. They're like $1.88 or something when they're in season. I don't know, whatever. So oranges are the same way. Over the course of a year, they change in value. So they are the most expensive the 3rd month of the year and the 5th month of the year. What would those be? March, May, March, and May. Those are the expensive. That surprises me for oranges. You would think that they would just like start coming ripe. I don't know when oranges do their thing. So as shown in the table, for each month starting in January in the graph of cost over time as a function, use the table and graph to estimate the extrema for this function. Then explain the extrema in the context of the situation. So we just said March and May were really, really, really high points, right? March and May are maximums. And let's see, do we have any other maximum points or really high points in relative to anything else around it?
No.
Not really. We don't have a place where it's going up and then coming back down. This one's going down and then it's staying the same and then it's going back down again, okay? So let's talk about minimum points. Do we have any minimum points? The 10th, right? So that would be October. And where else? Maybe, but if you really link these together, like and you put like the 12th month before the 1st month, it's going to look like this, right? The 12th month is here, so if you lump him back over there, that's not going to be really a high point or a low point. You see how that works? If we would repeat this one value over here, so we would go back to the 1st month, it would look like this, and then it would start going back up again, right? Okay? No. There's one more in there that's a low point. It's hidden. 8? Nope, 8's not a low point because it stays the same on the right side. It's 4. 4 is a low point technically, right? Just a little low point. So October and April, 4th month, okay? Those are going to be minimums. So this is where prices are lower, and these are where prices are higher. Prices dip a little bit in relationship to all the other points around it, and then prices are a little higher than what it was the month before and the month after. Does that make sense? Then explain the extrema in context of the situation. That's what we just did. Prices lower, prices higher. Good? Yeah? Okay. That's all.
That's all we have to do for that?
That's all you have to do for that. You're just analyzing graphs is basically what you're doing.